Primary one is in less than 55 seconds. Okay, so we have the actual data, sample of 8, and we don't know the mean, which we easily get. Okay, so they mark the WAC. Alpha 0.05. Okay, so remember, the 80 is always equal. Equal 55, equal 55, equals. So 80 is always equal. This is definitely right. Now, the alternative, which we're trying to prove the average is less than 55. That will make it a good product. Here, lower is better, and the faster is 2 times. So the answer is A. Again, if you don't, if you need more explanation beyond, let me know. But you got
Okay.
Should I check answer or want me to explain it?
It's I understand that one.
What do you say?
I understand that one.
Okay,
Yeah.
this is good. Now, then they say, what's the value of the test statistic? Statistic is, and that's where you can get from StatCrunch. If you go to, oh no, where's StatCrunch here? Sometimes they give you a little thing and get the
It's
numbers.
like in the 3 dots.
They don't give you that little blue thing. You have to type the numbers in by hand.
You have to click get more help.
Get more help. StatCrunch. But you could have to type in the numbers yourself, don't you?
Oh yeah.
Yeah, usually they make it easy for you. They just give you a little blue thing and you click on it and numbers go right into here. You'll see that in most examples. So let's type it in. 55.2. 6. You go into stat, because we don't have this, we could stat, one sample with data. I'm going to tell the computer we want our data is found in what I forget what they're asking. Office is testing. Mu equals 55 and mu less than 55.
Okay.
That we do want the significance value 0.05, I believe it. We just hit so the t-stat is minus 1.41. That's the number that they're asking you to find, I believe. It's right away. I lost my confidence, but 1.41 minus 1.41. Where's the problem again? Let's put a minus 1.41. P-value again comes out of the printout. I think I saw it there. It was 0.1007. You see that?
Yeah.
They market the wax. Now remember, if the rule is if the p-value is lower than the alpha they started with, which is 0.05, that means you reject the 80.
Okay. If it's less than you said?
In this case, it's bigger than 10%. 0.05 is bigger than 0.10. So no, there is insufficient, is less than 55 is the right answer. So no, there is insufficient evidence. That's you agree with that interpretation?
Yeah.
You sure? Because if you don't sound, might as well be sure.
Wait, okay, so you said if it's less than the test statistic value, then
Okay.
there's
The p-value, which comes out of the set bunch, is less than the alpha that they give you, or the significance level. Because sometimes it could be 1% or 10%. Usually it's 0.5%. And 10% is bigger than 5%, right?
uh-huh.
That means we continue to accept the A0, that the average truly is 55. We don't believe the HA. If this number would have been 0.00001, very small number, then we'd reject it. And we say there is sufficient evidence. Right now, no. Should we market the wax? No, because we're not. The new one isn't any faster than the old one. There is insufficient evidence to conclude the mean is less than 55, which is the HA. In other words, we don't believe this. We continue to believe the average really. In other words, this new wax is basically the same as the old wax. It may have a slightly lower average, but it's not really that much lower.
Okay, it makes sense.
That's the answer. And that's it. Oh, there's more. Suppose they decide not to market the wax. Okay, this again, if this, I do discuss this at length in the videos. This is like the theory part of the course, which again, you don't really have to know. I mean, it's nice to know it, but of course, if you're going to help me solve it, they'll always tell you the right answer. And you do it for the test, it'll be the same basic shape. But let me just explain it to you. There are two types of errors in statistics. One is called a type 1 error. The other is called a type 2 error. The type 1 error relates to the alpha, meaning we're willing to make a mistake. It's like called a false positive. We're willing to make a mistake saying this guy is right, even though it might be a 5% chance that it's luck. And as I'm hearing myself speak, I realize I'm really squeezing in about 3 hours worth of lectures into three seconds. So I don't have to too much unless you read it or watch some videos about it. But basically, there are two types of errors. This is called a type 1 error, the probability of a type 1 error. If you make a type 2 error, but let's assume, this new wax really is better than the old wax. But you just had bad luck in your sample and you end up concluding that it's the same as before. So it's another mistake you can make. In other words, you can conclude that the new wax is better than the old wax when you're really wrong, or you can conclude that the new wax is not better when you're really wrong. So there are two kinds of errors. It's called a type 2 error. And making a type 2 means they really should be marketing this new wax and they're going to lose the profit.
Okay.
All right. So, I mean, I'll be happy to talk to you at length about it, but in terms of answering the question, that's I'm sure is the right answer. But you should look at, I mean, you don't have to look at all my videos, but in these chapters about hypothesis testing, I really do, I think, a pretty good job of explaining from basics, all the theory about type 1, type 2, balancing them and what's going on here in a deeper way, as they would say in class that we had about this. But again, it's up to you. If you want me to explain it, at length, I would do that. So just decide.